Thanks everyone for joining today. I wanted to take the opportunity to brief the community on current status for Chandra. It's been a long year of activity with the observatory, and I know that a lot of people um, have been watching and waiting to hear what the final status is. Um, and I forget that sometimes not everybody is as caught up as I am. So let me go through a bit of a presentation here that sets the stage and hopefully answers questions that people might have from the community. So the first step is my slides don't advance. There we go. Um, so here's an outline. I'm just going to go through a status of the science status for the Chandra and the observatory status, then go through a description of the operating paradigm change review or OPCR process that we went through and describe the results of that, lead from there into what the current funding situation is for the observatory, and then mention the senior review proposal that Chandra is going through along with other missions. The slides from this will be posted on the CXC web pages after the end of the town hall meeting. So I will go through some things quickly because I present them here to give an idea of some of the issues, but provide more details than I think I need to go through here in real time. And you'll see what I'm talking about as I go along. So let's just start by setting the stage. Some of you, maybe all of you, are totally familiar with this already. For those of you who are not, what is it about Chandra that is so unique? The capabilities of the observatory are indeed unique, and they rest primarily on the exquisite mirrors for the X-ray observatory. The plot on the upper right shows the on-axis point spread function as a function of radius for the observatory. And what you can see shown there, I guess I can use my mouse, is the half power diameter of the point spread function is about 0.6 arc seconds. So that means the spot size in which 50% of the energy is contained is about 0.3 arc seconds squared, which is tiny. 90% of the photons from a source would be contained in a circle that's less than an arc second in radius. And for the ACES-I detector on Chandra, the background is about 7 times 10 to the minus 7 counts per second per square arc second. So what that means is that in a million-second observation with ACES-I, the background will produce about 2 counts in that resolution element corresponding to the 90% encircled energy. And this is what makes it so exquisite for looking at detailed structure, not only the very, very fine point spread function, but the fact that the background is low enough so that you are able to identify sources with very few number of counts and know that they are real. And what's shown here over at the left is a nice deep observation, 7 million seconds with the ACES-I detector. There's over 1,000 X-ray sources detected in this field, with more than 11 net counts in them, and 11 net counts is perfectly fine to establish that these are real sources in the field because of the high quality mirrors. The additional capabilities come from the high resolution spectrometers on Chandra, and they provide unique opportunities for both sub-arc second imaging, well, not only sub-arc second imaging, but also high resolution grading spectroscopy, especially in the 1 to 3 keV band, where the spectral resolution is actually higher than for calorimeter type detectors at current resolutions in any case. In addition, Chandra has a fast TOO, target of opportunity, and a director's discretionary time program with responses that support transient studies of transient sources, and a large field of regard. We can't look close to the sun, but we can look at all the rest of the sky. And so as a result of this, there's very strong capability for TDAM studies, time domain and multi-messenger follow-up studies with Chandra. We also have joint observatory programs with JWST, Hubble, XMM, NuSTAR, SWIFT, and others to support multi-wavelength studies that are so crucial to the types of science that all of us do. And the capabilities of the instruments on Chandra are still of exquisite quality as well. So the image sharpness and the grading spectral resolution have not changed since launch. Over on the right, there's a nice set of observations of the Orion Nebula, where you first see a deep observation, imaging observation, to resolve many, many stars in that stellar nursery. And then below it is a high energy transmission grading observation, where you can see dispersed spectra from many of the sources, the brighter sources in the central regions of that nebula. The ACES detector, as many of you know, because it's kept cold and because the observatory outgasses even after 25 years, there's a layer of contamination that builds up on the filter, and that buildup continues to slowly increase. And what that does is to reduce the effective area at the lowest energies. So since 2022, which was our last senior review, when Chandra was ranked a tier 1 mission, the effective area at 1.5 kilovolts has decreased since then by about 15%, and at 4 keV by about 1%. So those are measurable effects, but not ones that over that course of time have a huge impact on science capabilities. Put another way, if you think of a low energy cutoff where the effective area drops precipitously to a point where the quantum efficiency is 0.2 as a fiducial number, that ledge in the effective area has crept up from 1.07 keV in 2022 to 1.17 now. The HRC detector is operational. It's on its A-side power. I'll say a little bit more about the HRC later on, but it is functioning fine, and we've been taking a lot of observations with it in the past year and a half or so. The 2022 senior review noted that Chandra's unique and essential capabilities have no peer in X-ray astrophysics, and that there's no replacement on the horizon. And it's one of the things that makes Chandra so crucial and makes maintaining Chandra so crucial. Emphasizing that, I think, is the fact that in the 2024 probe studies that were announced recently, the selection of axis for phase A studies gives confirmation to the notion that high angular resolution in X-ray astrophysics is just fundamentally important. We who use Chandra all know and understand that. I think a large part of the astrophysics community in general understands that. And what this means is that continuing Chandra until there's a replacement in place is important for our entire field. There's a high level of productivity still on Chandra. I'm emphasizing some of these because some people here may not be familiar with it, and also because there are questions that we always have to answer every year. All of the missions have to answer, what have you done for us lately, kinds of questions. The oversubscription for Chandra is high. It's historically, the mission average is about a little over 5 times as much observing time requested as can actually be carried out. In the past 5 years, that's been a little over 4.5 for Chandra, so relatively stable for the 25 years of the mission. The recent Chandra Legacy program call for white papers, which I'll say a little bit more about later, was oversubscribed by a factor of 15. So clearly very significant demand for Chandra. The publication rate remains steady. You're all busy writing papers, and that plot up there shows that there's over 400 of them on average per year. So over the history of the mission, there's been over 10,000 so-called Category 1 Chandra science publications, ones where the paper is really all about the Chandra data, with nearly 500,000 citations. So very productive enterprise here. The legacy program that I mentioned was had a call earlier this year for identifying programs that were sort of fundamentally important things that one needs to do while one has a facility like Chandra. And there was a white paper that called for topics. Those were reviewed by a panel, and then 2 areas were selected for soliciting proposals. And the proposals that were awarded from a subsequent peer review were one that is a survey of nearby galaxies to probe baryon and energy cycles and binary evolution at high resolution. This is covering galaxies that are in the FANGS survey, which combined with the existing archival Chandra observations of some of those the galaxies in that survey will complete the coverage of all 74 galaxies in that survey. And there's already a large amount of existing multi-wavelength data on those. So the Chandra will bring the X-ray complement to that really important study of nearby galaxies. In addition, there's a program to carry out a deep observation of the Perseus cluster in order to study on a very detailed small scale level the physical processes by which feedback energy propagates across the core of the cluster of galaxies. So these are 2 important programs that are underway now, and we look forward to the results of those and to doing more of these kinds of programs in the future. The community that uses Chandra, many of whom are hopefully listening right now, is continually growing. We have, over the course of the mission, have always added about almost 200 new users each cycle of proposals. So the community is continuing to grow steadily. A lot of those participants are students and postdocs. The plot on the right shows a breakdown of about how many students and postdocs are involved in Chandra research each year. This is actually probably an underestimate because it comes from a survey of people asking how many students they have, and some of us don't always answer our surveys. So it's realistically probably more than this, and there's a breakdown showing how undergraduates, graduates, and postdocs are participating. Chandra has continued to produce about 26, or I should say Chandra data have supported about 26 researchers who produced PhD theses each year. And the funding to support those programs, which largely goes to students, postdocs, non-tenured early career researchers, is really crucial. And we recognize that. I'll say some more about that as we go along here. So this is a busy looking plot. I won't drag you through all the details of it, but the emphasis here is to get across the point that Chandra is in good health, functioning at a high level. This plot shows you a status of the various components that make up Chandra. What you want to know is this: blue means anything that's blue is operating completely, fully functional. So the batteries, the reaction wheel assemblies, etc., all perfectly fine. Anything that's green is also is also fine, but they're meeting all the requirements that were established at the outset, but they're not operating as stellar as they did at the outset. Anything that's blue and green on this is really great. Things that are yellow are things that are still working, but that require mitigation. And I'll talk a little bit about some of them. And things that are red are not functional anymore. So for example, there's a red thruster down here. This was a thruster that stopped working very early in the mission. There's a fine sun sensor over here. Sorry. There's a fine sun sensor over here that's not working. And the fine sun sensor, the second one, fine sun sensor B, is working, but it has some issues that we have to mitigate. However, behind that is a green coarse sun sensor, which is just operating just fine. And if the fine sun sensors should both stop working, we can continue using supporting the function that they were providing with the coarse sun sensor. There are some other things that are red here. One of them is a power supply for the high resolution camera. And one of them is a radiation detector that we use to monitor solar storms. We do that now with the ACES detector. The yellow items, HRC has, we're on the second power. We're on a second power supply. There was two. One of them isn't working anymore. And we do some mitigation to make sure that we don't exceed certain temperature and length of use restrictions for it. Other than that, it's fine. And the multi-layer insulation and thermal coatings are things that's the shiny stuff that wraps the telescope and is intended to reflect sunlight, and it doesn't reflect as well anymore. And that means that things warm up if allowed to be kept in direct sunlight. And so, of course, what we do is develop models to predict how those temperatures will increase and make sure that we don't have direct sunlight on those parts of the spacecraft for long periods of time. We maneuver to other attitudes, look at other targets where those parts of the spacecraft are viewing cold space to cool them off. So the increasing thermal trends that come from that multi-layer insulation degradation, that's been going on since about 2005 or so, and we've proactively managed that throughout that period of time. And in doing so, the plot on the upper left shows the observing efficiency for Chandra, and you'll see that the observing efficiency is very high. It's up about, the average is about 70% of clock time is actually spent on science. A large fraction of the time that's not on science is when we are in the radiation zones. So we have the instruments behind shielded boxes so that they don't get pummeled by energetic particles. And that was always expected that we wouldn't observe during those periods of time. So the observing efficiency is well above what our requirements were, and it's been steady for the entire mission, despite having to work on planning observations to make sure that we don't let anything get too warm. And we continue to study the observatory to monitor its behavior in every respect, and in particular, the heating of the different components. And in doing so, we look at whether the temperature limits that we've been working under actually could be relaxed by doing studies of the individual components and such, and look for ways to make sure that we can maintain the efficient use of the observatory. Many of you are familiar with the fact that the length of observations that we can carry out with Chandra without having to move to another source. So in other words, the maximum duration of an uninterrupted observation has decreased over the history of the mission. And some studies, some work that we've done recently has led to improvements on that front. The plot on the upper right in gray shows what fraction of the sky we can observe for these different amounts of uninterrupted observing time. So for example, for an uninterrupted 40 kilosecond observation, there's about 20% of the sky that we can look at and stay for that long. Anything longer than that would require us to break the observation into smaller parts. With recent studies and relaxations of limits to mitigate some of this, the blue curve shows where we will be in early next year. So we will have increased the availability of uninterrupted observing time across the large fraction of the sky to relatively long observations. And this is the sort of thing that the team just continually works on to try to maximize the science capabilities of Chandra. I mentioned at the outset, that there's a significant support for time domain science and other science that requires specific observing constraints on the observatory. So the plot on the left shows the number of targets of opportunity that were approved for each cycle in the peer review. The amount of time actually is what it shows. And the blue curve shows the total time that was approved. The orange curve shows the amount of time that was approved multiplied by the probability that the observers gave us for how likely it was that the observation was going to trigger. We take that multiplicative factor into account to make sure that we don't that we allow enough observations to actually make sure that we're getting as many done as possible. If we have a lot that have very, very low probability and they don't end up triggering, we don't want to go through a year where we miss the opportunity to do some transient science. So the green curve shows the total observed time in TOOs over the mission. And of course, we're in cycle 25 right now, starting some cycle 26 observations in January. We've actually done one or two TOOs from cycle 26 that we agreed to pull forward. So those 25 and 26 numbers they're not complete yet. We're still in the midst of those. But averaged over the past 3 years, Chandra has averaged about 40 TOO and DDT programs per year, which comprises about 60 observations and 100 observing segments. Those typically, or I should say sometimes, more often than not, require us to modify our observing schedules. That is, somebody says to us, this is really important. Could you interrupt what you're doing and do this as soon as you can? And 40 times a year, we do that. In addition, we support a lot of constraints on the observations themselves. People can submit time, phase, and role constraints. They may want to monitor something multiple times a year. They may want to look at a particular phase of a binary system. And that, of course, brings about unique science. And so we support as much of it as we can. And this plot over here gives an indication of the level of support that we've continued to provide over the history of the mission. In order to do all of this, we have teams of people who are, evaluating how to schedule observations, providing information to observers about how to best specify their observations, and more. And I'll say more about the more in a couple slides. But I just want to give you an indication for everyone who understands that ultimately the cost of the observatories and things that I'm here to talk to you about today, which is what's been going on with Chandra funding and such in the last year. This is important. So the plot on the left shows the basic breakdown in fiscal year 23, and I put 23 here for a reason. What the breakdown was for different tasks. And what you can see is that basically everything is either labor or it's Chandra grants. There's a little bit of extra additional money that goes to computers and other infrastructure, but primarily it's the labors through SAO, through its subcontractors. and then the Chandra grants. The number of people who, so why did I show it fiscal 23? As you'll see briefly, fiscal year 23, we were still operating in a normal mode where we sort of are doing the same thing with sort of the same level of funding every year. And then things happened after that. And if I were to show you the breakdown, then it wouldn't be representative of our normal way of operating. But I'll talk about that. This plot over here on the right shows the total program labor in full-time equivalent people as a function of time. And what it shows is that over the history of the mission, the number of people working on Chandra has decreased by about 42%. The flat line on the right is a recommended level of staffing that has been established through multiple reviews, both senior reviews and independent operations reviews who have looked at all of the processes and services that Chandra provides, and concluded that the staffing level is lean but appropriate for those tasks. The wedge over here for the Chandra grants historically has been about $10.5 million per year. That is not a very large geo budget. Chandra does not have a very large geo budget. That means that individual grants are generally relatively small, and I can't see you people, but I can hear you all nodding your heads. The entire budget is tight. So these slides I'm not going to go through in any detail, but I put them here so that you have a sense of where details are, and so that you can read them at your leisure if you want. But the point of these is to illustrate what it is that those people in the previous plot do. And so this diagram on the right is on a diagram that has you, the observers, at the center, and shows how the whole process works. We solicit proposals, we put them through a peer review, we lay out plans of observing, we send them up to Chandra, we receive data, we process them after applying calibration, we monitor the observatory, we use sources that were detected in these observations to build a source catalog, provide tools for data analysis and publication, etc. So pre-observation, before the observation, we're doing the peer review, the proposal user support, and the planning of running the observation with current observations. And then as a routine part of that latter step, we have a flight operations team that manages the spacecraft and keeps it safe and healthy, and sends the observations up, gets the data back down. Ground operations team to capture those data and deal with them. The science operations team that works with the flight operations team to make sure that the instruments are safe and operating properly, monitors the solar storms. Those of you who've enjoyed the aurora in the last couple of months, which I admittedly have, need to understand that many of us get text messages to our phones telling us to jump out of bed because those solar storms are coming, and our detectors are not fans of those very energetic particles. So we have to stop observing when that happens. Post-observation, we get the data down, we process it, monitor the spacecrafts, calibrate the instruments, take the calibration data, apply them to the data that are being processed, archive it all and distribute it to you folks, build the catalogs. This is really kind of a repeat of what I said earlier, all the way down to public communication that communicates press releases and image releases from your science results. We deliver a bunch of things that you all use to make best use of Chandra data. That includes a lot of different software for planning observations, the ObsVis, ProVis, PIMS, et cetera, as well as to analyze the data. The science user software is meticulously documented with analysis threads that make it easy for you and your students and postdocs to jump right in on Chandra data, even if they're not totally familiar with it. And what comes out of this is also processed catalogs, such as the Chandra source catalog, tools like DS9, et cetera. We run, this mentions the software threads that I had just referred to, and the documentation that's kept up to date as much as possible, and brought as much into the current computational frame as possible, for example, by providing Jupyter notebooks for certain tasks and such. The whole idea is to try to make it easy to get at Chandra data and do the analysis, make X-ray astronomy accessible to a broad range of researchers, and make it easy for users of other observatories to integrate X-ray analysis and X-ray results into their work. We of course provide a help desk with for answering questions about things, and we also run workshops and symposia to try to teach people how to analyze Chandra data. So we have taken workshops out on the road and introduced many different communities to the details of how to use the Chow software and the Sherpa software and such. And we produce newsletters and announcements to keep everybody informed, of course, of what's going on and what new things have happened with the observatory and with science results, and have workshops and conferences with specific science focuses every year to highlight what has been done, not just with Chandra, but what has been elsewhere in particular fields to stimulate ideas about what to do in the X-ray regime. And then finally, I mentioned before that we do public communications as well to communicate to the public at large what their tax dollars on science are going to, at least from the Chandra realm. And so we produce many different products for the public, not just press releases and image releases, but also exhibits in town squares, in airports. I saw it on the DC Metro earlier this year. We produce products aimed at making the results from Chandra accessible to people with less access to scientific information, including underserved schools, universities, but also in particular an effort on the blind and visually impaired community by producing representations of Chandra data in tactile form, in three-dimensional form, in sonification that many of you have probably heard about. And so all of these things help put forth Chandra results and increase the science knowledge based on what observations we've done. So all of that is the sort of backstory to where we are with funding and where we came into things at the end of last year, let's say, or during last year. The plot on the right shows the Chandra budget guidelines for various stages of things. The blue curve is the starting point for what I want to get across here. That's the approved funding level from the 2022 senior review for Chandra. The senior reviews are held every 3 years, but the budget horizons for them are 5 years, and so that's why there are 6 points on there. Okay, that's not why there's 6 points. One of those points was the amount of money we had that year, and then the other numbers are where the recommendations propagated forward. Um, and I just want to make a note about when the budget from that 2022 senior review, when the budget was approved, there were guidelines that were put forth with it as well. These were informed by the senior review and directed by NASA headquarters. And in particular, in blue here, I want to emphasize the guiding principle for use of the funding overguide that refers to the increasing amount of funding here, which is primarily about cost of living increases, and which do not always meet the cost of living increases that actually occur. So the guiding principle should be to maximize the science returns for the community by preserving the mission infrastructure while maximizing geo funding. And so this is what our projection was. And then in 2024, last year, we received multiple funding cuts that ultimately settled out at about a little over $3 million. So based on this guidance, we maintained the observatory infrastructure, and that $3 million came out of the GEO funding. That is the 30% reduction in funding from proposals in that cycle that many of you experienced. And that's how it came about. At that time, it won't surprise anyone that there was grumbling, even by friends who said, Pat, is this SAO just taking the money for the GOs to make them feel the pressure so that they will, make a lot of noise? And the answer is no. The answer is that this is what we were directed to do if we had budget shortfalls in that time frame. There was earlier, in fact, just prior to Senior Review 2022, there was another budget deficit that had to be dealt with, and there was a lot of discussion about how to deal with it. And certainly one of the suggestions was, well, we could solve this by taking a little bit of money out of the GO funding and solving the problem. That's not what we did. We let people go. We laid people off because I've supported students and graduate students just like the rest of you. And so have the other scientists and the CXC staff. We recognize, the importance of GEO funding, and we're fighting for it. But I do want people to understand that sometimes it is at risk and how that happens. So the dashed line here then, after that budget reduction was dealt with, that dashed line is a target that we were told to write a description of how we would deal with a reduction at that level going forward. This was in late last year, and we reported on it in January. It required a lot of thinking about how we, what we would have to reduce in order to do that. But in March, that's not the level that we were told that we were going to plan to at all. This is the level that we were told that we were going to plan to. This is the numbers from the president's budget release in fiscal year 25 from NASA. And so what we were told was that we needed to figure out a way to operate with more than a 40% reduction in Chandra in the first year, and operate at a level that was more than 60% below our normal operating levels after that. The immediate response to this was, well, we already have a budget that was requested from NASA some time ago for what it would cost were the mission to come to an end at some point from some sort of failure or whatever. And that closeout budget, which requires a lot of steps of final processing, final catalog, documenting everything that happened over the history of the mission, delivering data to an archive, et cetera, was higher than these guidelines. So these guidelines were only manageable with the decommissioning of the observatory. So that's what I mean by the budget has become turbulent. What happened was this, of course, was not out of any mean-spirited way of dealing with Chandra. This is all about in NASA funding on being lower than what we all want to see it at. NASA has budget difficulties. They have to find a way to fund everything that they want to fund. And one of the ways to try to do that was to look to both Chandra and Hubble as places where reductions might be able to be made so that they could have some savings. So an ad hoc review mechanism known as the Operating Paradigm Change Review, the OPCR, was created for a way to go to Chandra and Hubble to look for ways of reducing costs in their operating plans. Panels for this review were charged with evaluating the proposals that were submitted and issuing findings to NASA Astrophysics Division. The teams, the Hubble and Chandra teams, were presented with budget guidelines and directed to propose options that would meet them. So this table just reiterates what that plot just showed. It shows exactly the same numbers. So ultimately, as I mentioned, decommissioning was the only option for Chandra that would actually allow it to roughly meet these guideline numbers. So ultimately, we were allowed to submit up to 3 overguide options, meaning plans that were above those guidelines, cost more than what the guidelines were. We proposed 4 of them. One option was the closeout one. One option was a minimal mission, which I'll describe to you. Another one was that same minimal mission with geo funding, and then the last one was full funding for the observatories. The minimal mission was still above the cost of these guidelines for fiscal year 25 and well above them for the subsequent years. So what was this minimal mission? It was look at the observatory and take away every function that we could think of taking away that supports the science community, but does not impede the bare minimum ability to put observations on the spacecraft, get the data back down, distribute them to the, calibrate them, distribute them to the community and such. So it did everything in this table. It eliminated the GL program, meaning we no longer solicited proposals from the community. We instead only would get director's discretionary time requests through joint observing programs, and legacy programs that were in place. We would drop everything from cycle 26 that had just been solicited, remove the HRC camera from use, drop all archival research, and get NASA to support that through ADAP, minimize instrument modes for ASIS, minimize them really meaning not really build new ones. Place all of the software into maintenance mode, so no new updates to Chow, to Sherpa, to DS9. Just make sure that they continue to function. Same with our own internal data system. No additional work on the Chandra source catalog. No more Chandra conferences or symposia, training workshops for students. Freeze calibration for the HRC and gradings, and minimize it for ASIS. Eliminate the uplink support that we provide for users when their observations are getting ready to go, and reduce some other tasks for V&V, monitoring and trending of instruments that would increase some risk and decrease the fidelity of the instruments. Of course, we did this all in mind with making sure that our base level was still going to maintain safety for the spacecraft and the instruments. eliminating the bibliography tracking that I showed you plots about earlier on, return our usual working attitude of returning to science as soon as we can following anomalies, because this would be a reduced staff level and we wouldn't be able to support that as gingerly as we normally do, and introduce about 50% idle time for Chandra in order to simplify the planning and scheduling, lower the needs to maintain high fidelity thermal models and such, which of course would significantly reduce the observing efficiency. So this was the bare minimum mission that we could possibly construct. And we had a second proposed option, which is exactly the same thing, except that it contained geo funding. And it contained geo funding for the amount of observing time, which was only 50% of the normal amount. So it would have had 50% of what we typically have had for geo funding. This proposal was reviewed and along with Hubble's, and both Hubble and Chandra were found to be operating at high levels, in good health, good observing efficiency, productive, able to run for a long time in the future. The last statement down here from the reviewers, ending either of these missions now would be premature and would have a large permanent impact on science and the astronomical community. The takeaway is that the OPCR concluded that operating paradigm changes would have severe negative impacts on both of these missions. And with regard to Chandra's review and subsequent decisions about it, first of all, the panel looked at our proposed scenarios and agreed that the continuation of a scientifically viable Chandra mission was not possible within the funding constraints of the proposed budget, saying in their presentation, this is not a bluff. This is not a proposal that's trying to make it sound like things are harder than they are. They just can't be done for that level. NASA communicated a plan to fund the reduced mission concept that I mentioned, but the one with the geo funding, recognizing, as we had very strongly emphasized, that that was really a crucial thing to add if it was at all possible. And then following discussions, they also agreed to restore that 50% idle time that I described. And this says geo program, that means soliciting of proposals. So ultimately we had this reduced mission, but we were still going to solicit proposals instead of just having DDTs and joint observations. And we would have the full amount of normal Chandra observing time. Even though this was the option, that had the geo funding, remember that that's the geo funding that was for 50% of the idle time. When funding was restored to get the idle time back, it was not restored for the additional geo funding. Subsequent discussions with NASA led to direction that restored funding specifically targeted at avoiding any of the staff layoffs that were in that minimal mission. And so that's where we are right now. The fiscal year 25 funding is near recent levels, except for that 50% of the geo funding that is missing. And there's no support for archive and theory proposals. Cycle 26 was preserved, where the review was held, targets have selected, grants were awarded, except for archive and theory at reduced levels. And so, the glass more than half full synopsis is that Chandra avoided decommissioning, restored the GEO program, soliciting proposals, doing reviews with some funding, continues operating at historical levels of service. In the meantime, while all this was going on, got a legacy program going as well. And that's really, honestly, quite an astounding accomplishment. Um, and it happened from a huge amount of work that was supported massively by our Chandra Users Committee, by many members of the X-ray community and the general astronomy community, the public, the press, Congress, NASA. I need to emphasize that. I don't want to make it sound like NASA is the enemy here. They had to bend over backwards to try and find ways to make this happen, and they did. So I think that speaks quite well to the cognizance of the importance of Chandra. So lastly, or almost lastly, where are we now? We have this senior review that I mentioned before. This is the same plot that I showed you before, just have it at hand to reference. The senior proposal guidelines go back to exactly the same guidelines we had for the OPCR process. So in blue, Chandra is starting at risk again. We're starting with guidelines that are here. And we already know that we can't even close down the observatory with our normal decommissioning plan for this amount. So the plan going into the Chandra senior review is the following. We have to provide an in-guide plan and also an under-guide plan. Over-guide plans are permitted as well, and NASA's anticipating them. And so that's what we're going to do. That's what we're in the process of doing. And I'll say something about that on the next slide. But here I just want to point out that the minimum mission from the OPCR, the one that I described to you before, is not the exact minimum mission that we're going to put forth in the senior review proposal. We learned from the review, from the community, the CUC, and actually from and the OPCR panel, and even NASA themselves, that pushing it to the point where we weren't soliciting proposals from the community, where we would have 50% of the observing time just idle, was just a step too far. The cost savings is not worth the loss of science that would come from that. So we are not proposing that level, that step in the proposal. Our plans are underway. We've discussed them with the users committee. Our proposal's been through a red team review, including by the CUC chair, Dave Pooley, and revisions are currently underway. And this is what it looks like. The in-guide option, the option that would meet the proposal, the funding guidelines, is decommissioning the observatory. That's the only thing that could be done. The under-guide option is decommissioning for cheaper, for less funds. We would actually have to work with NASA to ask what in the normal decommissioning would we need to stop doing in order to reach an under-guide option. Stop doing in a closeout, that is. So going to the options of more interest here, the first option, or the two options, one option is the minimum OPCR mission, with the following exceptions. There would be enough staffing to make sure that there was a proposal cycle. We will solicit proposals and review them and everything like that. And the full amount of observing time is available. So those are both added back, and that increased the minimal mission that we had in our OPCR proposal by about $3.5 million. And then the GO funding for that additional 50% of time that we would be getting back, and that's about $5 million. So that comes to a total of about $60 million in fiscal 26 for this option. Go back to the list that I showed you of reductions that goes with it to remind yourself that that would be a very, very significant loss of support for observers in terms of software, in terms of training, and all the things we talked about, or I talked about a little earlier. And then second, the second overguide option is a continuation of the nominal mission, with two exceptions: no funding for guaranteed time observer research. This was required by NASA for these proposals, and So that's in there. And then some small additional savings from staff attrition and task consolidation that we've been able to do over the past year. And that total comes to of order $71 million. So the summary from all of this is that the Chandra capabilities are unique. At present, we don't have a replacement under development for Chandra, but its capabilities are absolutely needed for X-ray astronomy and all of astronomy. Axis selection for phase A studies emphasizes the point that the community and NASA recognizes the need for high angular resolution facilities, and continuing Chandra until a replacement is in place is really critical. The observatory itself is healthy and highly productive. I didn't say anything about the fact that early on in the process that was questioned. There aren't problems with the observatory. The OPCR panels very clearly and resoundingly confirmed that statement. So there's no showstoppers that would prohibit Chandra from continuing the kind of performance that we've been doing for a long, long, long time now through this decade and likely beyond, well beyond it. The senior review work is under review. The option for support of the full mission is our highest priority. I hope that's everybody's highest priority. There is a viable observing program of a reduced mission, but it would be one that has considerable losses for the community. And we hope everybody agrees that decommissioning Chandra would just be a tragic loss of a highly functioning great observatory. So the last thing is that cycle 27, there is a cycle 27, it's coming up. Call for proposals is going to come out December 19th. It'll solicit observations with ASIS and HRC with or without the gratings. Proposals will be due in March. Plans for that we had in place in discussions with NASA to move archival research to ADAP were approved, planned for the upcoming ADAP AO, and then funding issues at NASA caused them to back off of this. As a result, funding is still not assured for archival proposals, and the same is true for theory proposals. So rather than soliciting them again in cycle 27, we are going to issue a call for proposals that does not solicit proposals for archive and theory. We will wait for the senior review to see what happens for the funding for those which we are requesting. And then we will hold a separate call for those later on as soon as possible if those areas are funded. And lastly, the CXC is going to move to something called a distributed peer review for cycle 27 to sort of consolidate that process. And everyone will learn more about that in the near future. And finally, the 25 years of Chandra is being celebrated with our symposium in December in Boston. We hope a large number of you are there. We'll be looking forward to seeing all of you talking about the great Chandra results. And so please join us. And I don't know if that's all I have, and that's right at the hour mark. So sorry it took so long, but if there are questions that have been sent in and that Evan has collected along the way, I can try to answer them. Evan, do you have anything?
Yes, Pat. Are you able to see the Q&A questions at the bottom? If not, I can just read them off.
I probably can if I get myself out of full screen mode. So give me a second. Give me a second here. Oh, that would mean stop share. And Q&A. There we go. Yes. Okay. Constantine, does the Chandra team consider alternative funding sources such as private donations independent of NASA funding to support the Chandra telescope and offset its funding reduction? That's the first question. And the answer is that in the OPCR call for proposals, NASA actually said that that kind of thing could potentially be entertained. So we have talked to them. We don't have any such sources identified, but we have talked to them about whether that could be done and what it would entail. And Mark Clampin actually addressed this a little bit at the recent APAC meeting. Um, his statement was that if it was found that the alternative methods of funding or sources of funding um, met all guidelines and crossed all hurdles for federal agency um, shared funding, that could be considered. There would need to be, we were told this previously, there would need to be a formal request for information generated in order to solicit that kind of support. And at that time, we were told it could take about a year to generate such a request for information. Maybe it could be done faster. So that's the status of it. That would not be ruled out. We do not have anything in mind. If something comes along, we would certainly nudge NASA and say, consider this. It's a great observatory. It's an investment that has paid a lot of returns and is continuing to pay returns. If we can get help in supporting it, that helps all of NASA. Second, are there any official alternative funding programs to which, sorry, that question just went away for me. Um, uh, Evan, did you just dismiss that first one? Because I only answered the first part of it.
Sorry, yes. Let me just read it off.
Yeah.
Are there any official alternative funding programs to which Chandra GO awardees can apply for additional funding to offset the reduction in Chandra funding?
Yeah, so it's an excellent question, and this is what I was sort of getting at. There, to my knowledge, the answer to that is that for data analysis and interpretation kinds of proposals, NASA's ADAP program is well suited for that, but the current guidelines do not allow you to write proposals for primarily Chandra archival research to that program. One can write proposals that include Chandra data. So if one were to want to do a study that, involved, cross-correlating infrared emission from Spitzer sources with Chandra sources, and the Spitzer was the leading scientific driver, that would be appropriate. But with Chandra being the leading element, it's not accepted. And that's why we had worked with NASA to try to get Chandra to be allowable in the ADAP program. They understand it and they're in support of doing that. But we're not able to make it happen this year. Once it happens, I think that would be a good place to go, and it would be appropriate for us to hand that off to ADAP. They support multi-year year programs that Chandra was really never able to support with the amount of funding we had for archive. So that's really the main source, I would say, for that. Let's see, Mark says, will anything mentioned in this briefing change due to the completely new administration to be installed as of January 2025? I am as in dark, I am as in the dark on that, Mark, as you are. I don't know. It's really hard to predict. Oftentimes I have said, look, it doesn't really matter that much which administration or which, party, let's say, is in the leading the administration, because the support for NASA science and NASA initiatives in general is always, sort of strong with the U.S. population, and how can it not be with the kinds of studies that we do, right? But we're also in a time when major fiscal changes have been afoot, and the last 2 years or year and a half are certainly a sign of that. So I just don't have any prognosis about what the new administration would bring to this. Oleg, given the critical situation, were other non-government sources of funding explored, like giving guaranteed time to universities that pay for CXO operations, crowdfunding, blah, blah. Yeah, so I won't even read that last one. Well, I guess everyone can read it. So Oleg says nonprofit foundations contacting Elon Musk, dot, 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 because after all, X-ray does have X in it. But I think that I addressed that in answering the first question. We have not gone out to to try to do that yet. What we have done as a first step is to go to NASA and say, what would the parameters be on something like this? And um, we don't have a clear path on it. I don't think it's out of the question, but I don't think that we have a clear path on it. I would say that we've spent our last year working on multiple budget revisions and regenerations, and now we're in the midst of the senior review process. So we don't really have the resources to chase this right now anyway, but that is certainly something that we will keep in mind and keep our eyes open and keep asking about. Anything else? Okay, I know that that was long, folks, and I appreciate you listening along. Certainly, if you have additional questions, feel free to send them our way. And as I said before, I hope to see a lot of you in Boston in December. I promise it'll be good weather. So I think that's everything for today. Thanks and have a good rest of your day.